Introduction. In the world of statistics, few concepts are as fascinating and widely applicable as the normal distribution. Often referred to as the bell curve, this elegant symmetrical curve is more than just a mathematical idea. It's a reflection of how many natural phenomena, from test score to heights, tend to cluster around an average. But what makes the bell curve so special? Why it's called normal? And how does it help us understand the world around us? Today, come and join us to unravel the mysteries of normal distribution, explore its properties, and know the formulas of how to get the z-score. So sit back and relax because we will open our curiosity to the beauty of understanding about normal distribution.
Alright guys, today's discussion, our topic is normal distribution. Jenny, since you like studying statistics, can you explain?
Of course. So normal distribution is a probability distribution, or simply as normal curve is a bell-shaped distribution. For example, this is the bell-shaped distribution. So as you can see, why is it called normal?
Because it's the most common pattern in nature. In a large data set, most values cluster around the mean and fewer values exist at the extremes. Sounds convenient, but does everything really follow that so-called bell curve? Actually, yes. Think about our last math test. Most of the students got average scores, while only few got extremely high or low scores. My score being below average was just a part of statistics. This curve is symmetrical. The mean, median, and mode are all in the center. Most data points are near the mean. So, the highest point of the curve is where most people score. And we use 68, 95, and 99.7 rule to explain how data spreads. Sounds like a Wi-Fi password. No, it means 68% data falls within the 1 standard deviation of the mean, and the 95% data falls within the 2 standard deviation of the mean, and lastly, the 99.7% data falls within the 3 standard deviation of the mean.
Let's do a quick explanation about the properties of normal distribution. The distribution curve is bell-shaped. As you can see on our explanation here, this is a bell-shape. And also the curve is symmetrical about its center. So this is the symmetrical, and this is the center of our.
The tails of the curves flatten out infinite along the horizontal axis. So this is the horizontal axis. Always approaching the axis but never touching it.
Factors of the graph of the normal distribution may depend on the mean and standard deviation. So, what is the probability of the job applicants who are below 33 years old? First, we will convert it into z-score so that we can find the probability. We will gonna use this formula. First, we will convert it into z-score so that we can find the probability. We will gonna use this formula. Z equals to x minus the mean and divided by the standard deviation. Given value of x is 33 minus the mean that is given above, that is 35. And we will gonna divide it into the standard deviation of 5. So we will gonna calculate this 33 minus 35 divided by 5.
33 minus 35. It is negative 2, and negative 2, we will divide it into 5. We're gonna have negative 0.4.
First, we were gonna plot the z-score in our normal curve. That negative 0.4 we will find below, which is the left side of the normal curve. We're gonna use this table. We will gonna find 0.4, so the 0.4 is 0.1554. So this is will gonna be the formula. Zero point 0.5 is because the area of the normal curve is 1 or 100, so the left and right side is 0.5 or 50%. 0.5 minus 0.1554 is equal to 3,446 or 34.36%. That is the probability. Conclusion. In conclusion, through our discussion, we've learned that the normal distribution is a powerful tool for understanding how data cluster around the mean with its iconic bell curve shape reflecting the natural patterns of variability from the 68, 95 to 99.7 roll to the roll of z-score. We've seen how static helps us measure, interpret, and predict outcomes in the world full of uncertainty, whether it's test score, highs, or even Wi-Fi password. The normal distribution remains us that even in a randomness, there's order. So the next time you see a bell curve, remember it's not just a graph. It's important think and window into the hidden patterns of life.